Welcome back, everyone. So here's another example of using the first principles to find the derivatives of f of x equals to 1 over 2x plus 5 at x equal to 1. So we apply the formula again. So it's f dash x equals to the limit as h approaches 0 of 1 over 2 bracket x plus h plus 5 and then minus 1 over 2x plus 2x plus 5 over h. Now, in order to make it neater on the numerator, what we're going to do is we're going to make it one fraction. So what we do is we're going to times this numerator 1 by 2x plus 5, this numerator by 2 bracket x plus h bracket close plus 5, and then we're going to times the two denominators together. So after doing that, here's what we're going to get. So what we're going to have is this. So we're going to have we don't need that. So yeah. So that's going to be 2x plus 5 minus, and then bracket all of that. So it's going to be 2x plus h plus 5, close the bracket, and then over, and this is going to be 2 bracket 2x plus h plus 5, and then bracket 2x plus 5. All of that is going to be times by 1 over h. And I forgot the limit here. So the limit as h approaches 0, and then equals to the limit as h approaches 0, and then in here we can get rid of the bracket in the numerator. So what we're going to have is 2x plus 5 minus 2x minus 2h, and then minus 5 over all of that together. So that's going to be 2 bracket x plus h plus 5, and then bracket 2x plus 5, and then I can put actually the h in the front here in the denominator. From there we can simplify. So we have the 2x goes with the minus 2x, and the plus 5 will go with the minus 5. So what we're left with is going to be the limit as h approaches 0 of what's left in the top is going to be just minus 2h, and in the denominator is going to be h, and then bracket 2x plus h plus 5, and then 2x plus 5. Notice that I didn't get rid of the brackets in here. I don't need that, and that's going to save a lot of time, because if you're going to waste your time just trying to get that, you're going to lose lots of marks. So just don't do that. Just leave it like that, because eventually it's going to be neater. So next thing is going to be the limit as h approaches 0. And then from here, sorry, I could have cancelled the h with the h here. And what's left now is going to be, in the numerator is going to be minus 2. In the denominator, what's left is going to be bracket 2x plus h plus 5, and then bracket 2x plus 5. Now, what we could do now, we can apply the h equal to 0 into the formula. Just notice that the reason why we did all of that to get rid of this h in the denominator. Otherwise, is the formula going to be undefined, or the answer going to be undefined. So in here, that's going to be equals to. Now we can apply the h equal to 0 again. So what's left is in the numerator is going to be minus 2. In the denominator is going to be 2x plus 5, and then times by 2x plus 5. And actually, I can just make that equal to minus 2 over 2x plus 5 squared. And then from there, now I can apply the answer. So apply that x equals to 1 into the f dash x. So it's going to be f dash 1 equals to minus 2 over 2 times by 1 plus 5 squared, and that's going to be equals to minus 2 over 49. That's the answer. Okay, see you next video.